I did not write down the question in the textbook for this homework exercise, so I'll read it to you, and you should write it down. Given the function g of x equals the square root of 9 minus x, find the derivative using the definition of the derivative, and find the domain of the original function g of x and its derivative function g prime of x. Okay, so when they say find the derivative using the definition, they're telling us to use the limit as h approaches 0 or the limit as x approaches a definition. One of those two definitions that involve the limit. I'm going to use the limit as h approaches 0. So immediately, as usual, I would love to start off by just doing a direct substitution into this stuff inside the parenthesis. I'm using the definition g prime of x is equal to the limit as h approaches 0. Now remember, the function was the square root of 9 minus x. So the limit definition of the derivative as h approaches 0 is the limit of g of x plus h minus g of x divided by h. Okay, let's write that down as I've done at the top. G of x plus h, given the function g, is the square root of 9 minus parenthesis x plus h. And then I subtract g of x, which is the square root of 9 minus x, over h. Okay, so here's what I'm thinking. I'm thinking out loud here on paper so that you can follow my thought process. I'm going, I cannot do a direct substitution for 0, for h equals 0. I would love to, but I can't. And the reason why is that this function in parentheses is a rational function in h, concerning h. I'm just interested in h right now, not x's. It's a rational function. It's a fraction. All right? It is only continuous. Rational functions are only continuous on their domain, and in this case, we're only concerned with h. So we'll think about its domain in h. In other words, all possible h values that I can plug in here would be the domain. Well, since h equals 0 is not in the domain, do you see why? If I let h equal 0, I'll get a 0 denominator. So obviously h equals 0 is not in the domain. This function in parentheses, the entire function, is discontinuous at h equals 0. Thus, we cannot do a direct substitution of h equals 0. All right, we can only do that where the function is continuous. This one's discontinuous at h equals 0, so I cannot do a direct substitution. Therefore, we'll try to simplify the function in parentheses. And we do that by multiplying by the conjugate of the top over the conjugate of the top. Now, one more thing I want to say. That stuff in the parentheses, that's not g of x, of course. That's just g of x plus h minus g of x over h. We call that the quotient function. That's what we're taking the limit of, the quotient function. Okay, so let's multiply. Take the original function at the top, and we're going to multiply, take the limit of the original function multiplied by conjugate of the top over conjugate of the top. So we're writing down the original function that came directly from the top. That's the limit of the quotient function. This is to find the derivative. And we multiply that original function by conjugate of the top. Looks just like the top, the original top, but we put a plus in between instead of a minus between those two terms. Over conjugate of the top. Got to have the same thing on the top and bottom. Okay, now we're going to go through, we're going to use the formula for the top. On the top we have a minus b times a plus b. So that's just a squared minus b squared, which means we take the first expression, the first radical, and we square it, minus the second radical squared, a squared minus b squared. And don't mess with the denominator. It's just too crazy right now. Just leave it like it is. Okay, so simplifying the top, where we're taking the square root squared, well, the square root squared, the square obliterates the square root. So we just have 9 minus parenthesis x plus h minus parenthesis 9 minus x over that entire mess on the bottom. Now we're going to get rid of the parentheses on the top. Just work on the top. And we get 9 minus x minus h minus 9 plus x. And then just bring down the bottom. And you see a lot of things are going to be canceling in the top. This gives us the limit of negative h over the mess on the bottom. Now, negative h was all that was left in the numerator, but it's a factor of h, and it's going to cancel with a factor of h in the denominator. So what I have on the top is negative 1. Now, I got lazy and I forgot to write my negative, but you can see that there is a negative in the numerator, and I'll fix that in just a moment. Okay, so at this point, I ask myself, this new version of the function, can I do a direct substitution of x equals 0 in this new version? In other words, I'm asking, is this thing continuous at h equals 0? And the answer is yes. If I plug 0 in for h, I do not have any problems in the denominator. It doesn't give me a 0 denominator. So now h is in the domain of this bracketed function in terms of h. Therefore, I just go ahead and let h go to 0. I do a direct substitution of h equals 0, and I get minus 1. Now I've corrected my negative sign on the top. Minus 1 over the square root of 9 minus x plus the square root of 9 minus x. That's what happens when I let h go to 0. Well, those are two terms on the bottom that match, so I've got two of them. It's negative 1 over 2 times the square root of 9 minus x. So I'm putting a box around that answer. What is that answer? That answer is the derivative of the function g of x. In other words, it is equal, that boxed answer is equal to g prime of x. So now I know two things. I know the original function that they gave me, which I neglected to write at the very top, and that is given g of x equals the square root of 9 minus x. And I know the derivative function, g prime of x is equal to what I boxed, negative 1 over 2 times the square root of 9 minus x. So I have two different functions. They asked me to find the domain of the original function g and the domain of the derivative function g prime. And my answer is, well, the original function was the square root of 9 minus x. So its domain is any value that makes the radicand, the stuff under the radical sign, greater than or equal to 0. And that would be everything from negative infinity to 9, with a boxy bracket on the 9, because we're including the 9. 9 is no problem for the original function, g of x equals the square root of 9 minus x. We would just get the square root of 9 minus 9, which is 0, and that's not a problem. Okay, so that gives us all non-negative values under the radical sign. But the domain for the derivative function g prime, which I mistakenly wrote as f prime, it should say g prime. Okay, pretend that's g prime. It is going to be the values of x that are legal in the boxed solution. And this time it would be everything from negative infinity to 9, but not including 9. I have to put a round bracket on it, because now if I let x equal 9 in this new function in the box, it would give me a 0 denominator. I cannot have a 0 denominator. In the original function g of x, there was no denominator, so that wasn't even an issue. Here it is. So that's the difference between these two solutions. The domain of the original function g includes the 9. The domain of the derivative function excludes the 9, because it would give us a 0 denominator. And we are finished.